Hello and welcome. I invite you to join me on a most extraordinary journey, a voyage through the very fabric of reality itself. We will begin our exploration in a realm so infinitesimally small, it defies our everyday comprehension with the tiniest conceivable measure of space. From there, we will travel outwards, step by step, witnessing the intricate assembly of matter. From the fundamental particles that form everything we know, to the complex structures of life, and eventually to the grandest scales imaginable. This is a story of scale, a narrative that connects the subatomic to the cosmic. Prepare yourselves, for the sheer magnitude of this journey is almost certain to astonish. The distances and sizes we will encounter will stretch the limits of your imagination, revealing a universe far more vast and intricate than we can possibly perceive from our human perspective. It's a humbling experience to grasp our own place within this immense cosmic tapestry. The world, and indeed the universe, is full of wonders, and today we shall attempt to appreciate its true, mind-blowing dimensions. So find a comfortable spot, quiet your mind, and let us begin. We are about to embark on an odyssey from the quantum foam, the very bedrock of existence, all the way to the edge of the observable universe. The scale of what you are about to see is not just large, it is profound. It tells the story of everything. Let us begin our descent into the world of the unimaginably small. Our journey begins here, at the absolute limit of measurement, the Planck length. It is a scale so profoundly small, so fundamentally minute, that our conventional laws of physics begin to fray and dissolve. Imagine a single millimeter on a ruler. Now divide that millimeter by 100 trillion. The result is a length so tiny that it is considered the quantum of distance itself, the smallest possible pixel of our universe. Below this, the very concepts of space and length as we understand them cease to have meaning. It is the ultimate foundation. Here, in this realm of quantum foam, space-time is not smooth but a roiling, chaotic sea of possibilities. Tiny wormholes and fleeting universes may pop in and out of existence in moments too brief to measure. This is the bedrock upon which our reality is built. A world governed not by certainty, but by probability and pure, unadulterated physics. It is the starting point of everything, the most fundamental note in the symphony of the cosmos. From this infinitesimal point, all complexity, all structure will eventually emerge. As we ascend from the abstract limit of the Planck length, we encounter the first true building blocks of matter quarks. These are elementary particles, fundamental constituents that, as far as we know, cannot be broken down any further. They are sociable creatures, never found alone in nature, always binding together in groups to form the larger particles that populate our world. There are 6 flavors of these quarks, whimsically named up, down, charm, strange, top, and bottom. It is from the simplest of these that the world we know is constructed. They are bound by the strongest force in nature, aptly named the strong nuclear force. This force is so powerful that it acts like an unbreakable cosmic rubber band. The further you try to pull 2 quarks apart, the stronger the force pulls them back together. It is this incredible strength that ensures the stability of the matter all around us. Within every object, every substance, these tiny, elusive particles dance in a constant energetic ballet, the unseen architects of the material universe, forming the very heart of the atoms that make up you and me. Now from the quarks, a familiar structure emerges. When 2 up quarks and 1 down quark are bound together by the immense power of the strong nuclear force, they form a new, more complex particle, the proton. This tiny, positively charged entity is a cornerstone of our universe. Protons, along with their neutral cousins, the neutrons, gather together to form the incredibly dense heart of every atom in existence. They are monuments of stability, with a lifespan so long it is predicted to far exceed the current age of the universe. The number of protons within an atom's nucleus is what defines it. One proton gives us hydrogen, the most abundant element in the cosmos. 6 protons give us carbon, the basis of all known life. 82 gives us lead, a dense and heavy metal. Each element, with its unique properties, owes its identity to this simple count of protons. They are the gatekeepers of chemistry, the masters of the periodic table, and within their tightly packed communities, they hold the potential for all the complexity we see around us. We zoom out once more, and the nucleus of protons and neutrons gains a companion. A cloud of much lighter particles, electrons, orbits this dense core, held in place by the electromagnetic force. This complete structure is the atom, the basic unit of a chemical element. For all their internal complexity, atoms themselves are almost entirely empty space. If a nucleus were the size of a marble in the center of a grand cathedral, the electrons would be like motes of dust swirling near the distant ceiling. Yet it is this vast emptiness that dictates how atoms interact. And interact they do. Atoms are the socialites of the universe, constantly seeking to bond with one another, sharing or trading their electrons to form molecules. This endless dance of atomic combination is what we call chemistry. It is the force that binds water, forges rock, and allows air to exist. Every solid object you can touch, every liquid you can drink, every gas you can breathe is simply a vast collection of these atoms bonded together in an almost infinite variety of configurations. They are the letters in the alphabet of the cosmos. Now, our journey takes a remarkable turn from the merely physical to the biological. Here, among the countless combinations of atoms, one particular molecular structure stands out for its extraordinary complexity and profound purpose: deoxyribonucleic acid, or DNA. This magnificent double helix, a twisted ladder of atoms, contains the instruction manual for life itself. It is a code, a blueprint written in a language of 4 chemical bases that dictates the form and function of almost every living organism on our planet. It is, in essence, the software of biology. Within each microscopic strand is a staggering amount of information. A single human DNA molecule, if uncoiled and stretched out, would be about 2 meters long, yet it is packed into a cell nucleus 1,000 times smaller than the head of a pin. This incredible feat of natural data compression stores the complete set of instructions for building a living being, from the color of its eyes to the rhythm of its heart. It is the thread that connects all life, passed down from generation to generation in an unbroken chain stretching back billions of years. Following the instructions encoded in DNA, we arrive at the next level of organization, the cell. This is the fundamental unit of life, a bustling, self-contained metropolis of molecular machinery. Each human cell is a marvel of biological engineering, a complex system of organelles working in perfect harmony. The nucleus acts as the city hall, housing the DNA blueprints. Mitochondria are the power plants, generating energy to fuel all activities. Ribosomes are the factories, assembling proteins according to the DNA's instructions. And the cell membrane is the city wall, controlling all that enters and leaves. A single human cell is a world unto itself, carrying out thousands of chemical reactions every second. It can communicate with its neighbors, transport nutrients, expel waste, and, most remarkably, create a perfect copy of itself. It is here that the abstract code of DNA is translated into the tangible, dynamic processes of life. We often think of ourselves as single beings, but in reality we are vast colonies, thriving ecosystems composed of trillions of these individual living units, each one a testament to the power of biological organization. And now, we arrive at a scale we know intimately ourselves, the human being. We're not just a single entity, but actually a cooperative of, 37 trillion cells, all working together in concert. From these cellular building blocks, tissues emerge, which then form organs, and those organs in turn make up complex systems, like our digestive, circulatory, and nervous systems. It's honestly an organizational masterpiece, where trillions of individual parts are collaborating to create a single, cohesive, and mobile being. The complexity that began with quarks has now resulted in a creature capable of movement, thought, and even emotion. But what is truly extraordinary at this scale is the emergence of consciousness. Somehow, from the intricate network of 100 billion specialized cells in our brain, the phenomenon of self-awareness arises. We are, as far as we know, the universe made aware of itself. We can look back down the ladder of scale to the atoms and quarks from which we're made, and we can look up, out into the cosmos, and wonder about our place in it all. This ability to question, to explore, and to understand is perhaps the most remarkable development on our journey so far. We now take a giant leap outwards, leaving the individual to view our collective home, the planet Earth. This beautiful blue sphere, suspended in the blackness of space, is a geological and biological marvel. It is a dynamic world of shifting continents, churning oceans, and a protective atmosphere that shields us from the harshness of space. Its molten iron core generates a magnetic field, a vital defense against the solar wind. It is a system of breathtaking complexity, where geology, chemistry, and biology are all deeply intertwined. This is, to our knowledge, the only place in the universe where the conditions have been just right for life to not only emerge, but to flourish with such astonishing diversity. From the deepest oceanic trenches to the highest mountain peaks, life has conquered almost every available niche. This thin, fragile layer of life, the biosphere, has in turn shaped the planet, producing the very oxygen we breathe. Our world is not just a rock in space. It is a single, vast, interconnected ecosystem, a living planet that cradles us all. Pulling back further still, we encounter the dominant force in our celestial neighborhood, the Sun. This colossal sphere of incandescent plasma is the heart of our solar system. Its immense gravitational pull holding Earth and all the other planets in their orbits. It is a star, a gigantic nuclear fusion reactor, converting hydrogen into helium in its core. This process releases a truly unimaginable amount of energy, which radiates outwards as the light and heat that make life on Earth possible. It is the ultimate source of almost all energy on our planet. The Sun is so vast that you could fit more than 1 million Earths inside it. It accounts for over 99.8% of all the mass in our entire solar system. Every second, it fuses about 600 million tons of hydrogen, a rate of consumption that it has maintained for 4.5 billion years, and will continue to do so for another 5 billion. It is a constant, reliable presence in our sky, but it is also a dynamic and sometimes violent star, producing solar flares and ejections that can have a powerful effect on our own world. We take our final and most profound step back. Past the planets, beyond our solar system, past the billions of other stars in our Milky Way galaxy, and past the billions of other galaxies that drift through the void. We have arrived at the largest known structure, the observable universe. This is the cosmic horizon, a sphere with a diameter of about 93 billion light-years, representing the farthest we can possibly see. It is the extent of the cosmos from which light has had time to reach us since the Big Bang. Within this colossal expanse, there are estimated to be at least 2 trillion galaxies, And each of those galaxies contains hundreds of billions of stars, many of which likely have their own planets. The sheer number of worlds is beyond human reckoning. These galaxies are not scattered randomly, but are arranged in a vast, web-like structure of filaments and voids. And it is here, on a pale blue dot orbiting an average star in an ordinary galaxy, that our journey began. To see it all laid out is to understand our true cosmic context. We are a small part of an unimaginably vast and magnificent whole. And so, our journey from the quantum realm to the cosmic horizon comes to an end. We have traveled across more than 40 orders of magnitude, from the fundamental limit of space itself to the edge of everything we can see. It is a scale that is both humbling and empowering. To know that we are built from the same fundamental particles as the most distant stars, that the laws of physics that govern a proton also orchestrate the dance of galaxies, connects us to the universe in the most intimate way. The complexity of a single cell is, in its own way, as awe-inspiring as the vastness of the cosmos. This voyage through scale reveals a universe of profound beauty and intricate order. Every level of existence, from the DNA molecule to the great galactic filaments, is a world of wonder waiting to be explored. We are incredibly fortunate to live in an age where science has granted us the vision to see these hidden realities. The story of the universe is the story of scale, and it is a story that is still being written, with new discoveries pushing the boundaries of our knowledge every day. What other marvels lie waiting to be found? I am left with a sense of profound wonder, and I hope you are too. Which part of this immense journey surprised you the most? Was it the chaotic world of the Planck length, the intricate machinery of a cell, or the sheer mind-numbing number of galaxies? Please share your thoughts in the comments below. If you found this journey through the cosmos as fascinating as I did, please consider liking this video and subscribing for more explorations into the mind-blowing world of science.